of the session. All right, our next speaker, moving on, dressed in almost head to toe tomatoes, is Dr. Jeffrey Zahn from Utah Valley. And he is going to talk to us about how he incorporates research into his undergrad courses. I'll turn it over to you, Jeff.
Thanks. Thank you, everybody, for coming out. If you look really closely at our most recent program, there's actually a typo in the name of this session. Instead of lessons, it says lesions in education. I like to think that accidentally refers to this talk because in a very real sense, I'm going to try to convince you to take out some of the content from your mycology courses, especially for an undergrad setting. And this kind of comes from my experience. I didn't take mycology until graduate school. And as you might expect, 6,000 level graduate mycology course, very heavy on terminology, lots of confusing phylogenies that are all different now, by the way. And the actual science was limited to observations and drawing and really detailed kind of stuff. That's great because I wanted to be a mycologist. But the university I'm at, we don't have a graduate program in biology, all right? It's primarily undergraduate institution. It's very large. We've got about 40,000 students. Demographically, a lot of them are older, a lot of married students, families, and about 50%, give or take, are first generation students. Neither of their parents went to college. Okay, so I had to ask this question, who is going to take mycology as an undergrad? And so here's a breakdown of the majors. As you might expect, most of these are biology majors. Okay, but of course there's, everyone's going to be a doctor, right? Or a dentist. And so a lot of my students have a medical career in mind. And no, not all of them will make it, but they don't know that yet. And you can't convince them. All right, there's also biotech, chemistry, bioinformatics now our new major, business, math, and art students taking mycology. And so how can I maximize this course? I've got a captive audience. Like, what can I do to benefit these students? And I've got a pop quiz for you here. All right, you don't need to answer this, but just raise your hand if you know the answer. Looking at this clamp connection, which direction is this hypha growing? There's a few of you. Okay, great. What is the name of this feature? More, good, good. What is this molecule? All of you should know all of these. But my students shouldn't necessarily have to know all of this when they come out of my mycology class as an undergraduate, okay? And so I'm looking at the demographics here, their career goals, trying to meet my students halfway, and I'm thinking maybe one of the best things I can do is train them as a scientist. And so reducing some of this domain-specific content knowledge might be a way, okay? Now, I get it. Maybe not teaching your mycology students about mycology is a bad idea. So grain of salt here, but this is what I've kind of hit on so far. All right. And this is kind of the way out for me. This idea, the cure, the course-based undergraduate research experience. This is not a new idea, all right? There are papers going back in the pedagogy literature, a decade or more, looking at what a cure does, teaching your course as a research experience, how that affects something like a student's science identity, their persistence in a STEM degree, okay? How they develop those scientific skills that are so hard to teach, but come with hard experience. Can we give them that experience within the classroom, okay? Do they have self-confidence? Do they say, I see myself as a scientist, right? And so the cure is really based around, we're at the point where there's competing textbooks, so it's kind of like not a new idea. But every source out there kind of hones in on these four things. A cure has novel data, right? There's that element of discovery. Okay. This can't be a data set that's 2 years old that you've analyzed before. This is something that students need to be excited about. High levels of collaboration. Very few of us get any scientific work done by ourselves, right? That hasn't happened in a long time, okay? And so that's a major skill for them to learn. They're learning the process of science less so than the right answers, okay? Whether or not they know that that's an adaxial drop isn't super important to me, as long as they know how to look that up, how they might go investigating a structure like that and what it might do, okay? And then the fourth pillar here is relevant topics with external interest. That means that there's got to be a way for them to do what we do, which is communicate science. There needs to be a reason for them to do that. I think that mycology is the perfect subject matter to teach a cure. As we've seen, there is growing public interest in fungi. Thank you, Netflix, right? People are excited by these. They're beautiful organisms. They're easy to work with in the lab, typically, depending on what organism you're using. Students come primed, excited to class. Okay, so when I first taught mycology, I had 8 students, and after the Netflix documentary came out, there's a waiting list of 20, right? So people are getting excited about fungi. They want to learn about them. They want to play with them. Okay. So I'm going to show you some example posters from these. This is output from my cure students in a single semester, undergrads who had no exposure to mycology. Okay. So they're doing things like investigating Darwin's naturalization hypothesis. How does phylogeny relate to competition? All right, so they're using fungi there. Looking at, the latent decomposer hypothesis. What are endophytes really doing in leaves? Okay, so are they the same things found in the litter as in the live tree? That's kind of fun. Okay, discovering new fungal species. So these students are learning about, how to sequence things, how to describe fungi. Comparing fungal endophytes in conventional versus organic brassicas, right? So these are pretty simple projects. They can get done in the timeline of a 16-week semester if you kind of push things along pretty fast. They're learning about how to make a scientific poster, and I love this title, "We Found Fungi That Kills MRSA." I was working with them on, like, you need to be more direct with your title, tell people, and they took it literally. So I just let it go. I love that. Okay. Bioremediation, there's fun stuff, but the best stuff, those were just the ones that worked. The best projects are the ones that totally fail, because that's 90% of all the research we do. Okay. And that's an awesome educational opportunity. So these poor students spent the entire semester trying to get chytrids to grow. That's as far as they made it. I still made them do a poster, right? But they learned about failure, and at the end of the semester, they're writing up their reflection on this, and they had a lot to say. And they had a fairly comprehensive knowledge of the papers that deal with cultivating chytrids. They just couldn't get it to work. Okay. And of course, there's the recent failure. This team here, I think this one was going to go all the way. They were interested in how leaf endophytes might shape root phenotype. All right, so they're using radishes here. One of them had taken my R-Stats course, and so she was kind of familiar with R, goes out and learns the Archidart package. We're starting to collect some data, and she says, let's make some transparent soil. So they find a paper on how to make transparent soil. They get it to work, it's going, and then COVID hits. Disaster. But of course, that happened to all of us. That's part of science. Okay, and here's that kind of fourth pillar. At the end of the semester, students are presenting their work. They're sharing this with the other professors at the school, but largely with their peers. Okay, so this is creating a culture of research as pedagogy, as let's do undergrad research, because people are walking by in the atrium on their way to lunch, and they're saying, "Oh, you can play with fungi and get credit for it? I'm going to sign up for that." I hear Dr. Zahn wears a tomato hat sometimes. Okay. So I'm going to give you an example from just one team, kind of walk you through this guided research experience. And They're going to learn the research essentials. They're going to design an experiment, carry it out, and interpret and communicate their data. All right. So the first minute of the first day of the first class, right? I walk in, and before we talk about the syllabus or introductions, I'm writing these 4 topics on the board. These are the topics that I think that I could get away with mentoring this semester with my schedule and the supplies I've got around. And 3 students chose the top one. Can you get yeast to evolve greater alcohol tolerance? Real straightforward. We've got an art student, a pre-dental student, and a wildlife biology student. And they're like, yeah, let's do that, I guess. All right. So they sign up and they go for it. Well, there's a lot to do. They've got to learn the essential experimental techniques. Okay. And some of those techniques are, well, to start with, how do we do research? How do we find out what we don't know about this right now? Where do we find our methods? And so they've got to learn about Google Scholar and Zotero, not Mendeley, because I'm a good person. And Sci-Hub, again, because open science, and I'm also chaotic good. But how to follow the citation trail. So yeah, we find a paper, where did this come from? What context was that in? This is all kind of new to them. These are undergrads, sophomore, junior level, a lot of them. And so this is the first time that they're really following the citation trail. And so they get, roughly 2 weeks to like dig into the literature and come up with an annotated bibliography. During this process, they're starting to learn that the experiment's not going to be as easy as they thought, or maybe they could change this or that. So, they encountered this idea that alcohol dehydrogenase is important for tolerating alcohol from a paper. And so then they realized that, hey, they've got a whole website where you can just buy yeast strains with this gene knocked out. So they wanted to complicate things a bit and bring in these ADH knockout mutants and see if there was any difference for these, 5 different ADH knockouts when they're evolving their increased alcohol tolerance. Okay. So then what I have them do is actually write this up as a proposal. So they're learning about the grant writing process, which is how do I make somebody care about the science I'm about to do? That's kind of a deeper scientific thought process, right? You're looking into yourself. Why would somebody care enough to give me money to do this? That makes students think a little bit deeper than if they're just doing a lab, right? So we talk about intellectual merit and broader impacts and learning outcomes. The methods get developed at this point. We budget out the supplies we're going to need. And then, of course, we come up with a backup plan because things aren't going to work. Okay. And so they submit this to our College of Science for internal funding, and hopefully they get, between $300 and $1,000 or whatever, just a small grant to kind of get this done. Okay. So now we're waiting for supplies. Now, some of these supplies I've got left over from the previous semester. Some are just always in stock in my lab, but there's a lot to do here. All of you have worked with undergrads or are an undergrad, and every time you ask them, do you know how to pipette? They say yes. But the answer should be no, right? So we're learning how to pipette correctly and how to do aseptic sterile technique. And in this time, we're also starting to read some formative mycology papers. And yeah, some of them are older than 5 years, but they're there for historical context. They can practice. So I just bring in some baker's yeast. Can you guys get this to grow sterile? Can you, calculate the OD on this correctly and do serial dilutions and all that kind of stuff? Okay. But there's also the planning for statistical analysis. And so we're talking about ANOVAs and time series and stuff that they heard about in statistics class, but didn't actually use in a real setting. Okay. So they're bringing in other bits of coursework that they've been exposed to that never really made sense. They haven't been using it. And so here we go, we're going to use it. All right. So the supplies arrive and the students are actually super excited. It's Christmas morning. Our yeast strains are here. They're ready to hit the ground running. This is the art student from this group getting super nerdy about yeast cultures. It turns out that she wants to be a scientific illustrator. So as we're learning about ANOVAs and stuff, I'm also talking to students about their lives and just being a normal person around them. Comes out that's what she wants to do. So if anyone had an opportunity to stop by Kate Hickman's poster yesterday, you saw this beautiful illustration there of the mangrove that comes from Lauren, just a chance encounter with a mycology student who wants to be an artist. Well, is an artist. She's awesome and available for hire. Okay. So they hit the ground running and immediately crash into a brick wall with the first data not making a whole lot of sense. Okay. This is where the real learning happens, right? So they've got growth curves. They're working really well, but there's some weird stuff in there. And they're thinking, you know, what's going on? Dr. Zahn, what's the answer? Well, I don't know. Let's look at the data. Let's go back to your lab notebook. Did you take it really seriously? Well, not so great. Okay. Well, guess what? Their lab notebook turned from short little notes into the Brothers Karamazov after this. It was just every detail, right? This is a new feeling for them, this idea of failing at science and not being able to understand it. I know it's a warm blanket of comfort for all of us. We've lived with it for so long, but this is new and it's scary. They actually need a bit of moral support this time, okay? So the 4 steps here turn into the reality of science, which is what the hell's going on, okay? How do we go back and how do we change this up, right? Well, the spoiler is that they did get it figured out. It was just bad pipette technique, of course, okay? And they got their nice growth curves and found out the alcohol tolerance for all these 6 strains of yeast, and then did experimental evolution with gradually increasing ethanol. And they got some weird results. Some of these ADH mutants increased their ethanol tolerance, right? After about a month of selective pressure. Some got worse. And so now we're learning about how evolution isn't always this straightforward, predictable thing. They heard that in their evolution course and intro biology, but here it is for real. Okay. And so they got this poster and they present the poster. But the important thing is when they're coming to synthesize their information. Okay. And so the student reflection, I think this is kind of the most important thing, right? And so we've got comments like, I want to be a scientific illustrator. This is really the only research experience I'm going to have in my undergraduate degree. I learned about collaboration, okay? I'm preparing to attend graduate school. I didn't know about, hey, you've got a budget for a science project. We got to plan for that and really think out the project ahead of time. I'm going to go to dental school. This required me to apply the knowledge I've gained in other classes to make the correct calculations. Okay, so going back to that chemistry course where we learned C1 V1 equals C2 V2, the best equation ever, right? And there's also feedback from me on what I could do better. Okay, so we should do possible rotations into other groups to learn concepts outside of our specific research. Okay, so yeah, I learned a lot about yeast evolution. I can work with fungi now, and you know, I've got a better understanding of what statistics are actually used for and how to make a poster. But I didn't really get to spend time learning about order of arrival and how that affects wood decomposition. That seemed really cool. I didn't know much about it until the poster session. So I think that's a great feedback that I'm going to try to incorporate next semester. I wish we could have read more papers and talked to more mycologists about their work. Well, that's kind of on all of you. Okay, so I am going to try to do more. So far, I've just been doing one mycologist guest to kind of meet with students, discuss their paper, not from the academic side, because you know they've had their little quiz on the paper and we've talked about it in class, but to meet a mycologist as a person and get the story behind the science, right? And so we had Natalie Christian on talking about, you know, leaf endophytes and litter and cacao, but she's also got awesome swashbuckling stories about trekking through the jungle and climbing up the stairs to put her pots of cacao plants. And this is just a person who does cool stuff and also was an undergraduate at some point. This is really good for students. I can see myself as a scientist. I too am a real person. I'm not just this brain that's pumping out papers. Okay? So I'm going to try to do more of that. So look for emails from me to kind of join our class on Zoom and just chat about the story behind your paper. And this is the tough one here. I wish we could have spent some more time up front learning about fungi. Yeah, I started the class doing that, but time is so limited. I got to finish this project in one semester that I started cutting down the mycological content. So I'm trying to find kind of that happy balance. Okay. So some lessons, hard won lessons that I might try to share with you if you want to try a cure. Um, Start with some topics that you're willing to facilitate. Don't let students choose anything. I tried that, it failed. Also, don't assign students to projects. That failed as well. They're not bought into it. And so what I found works really well is to, put 4 or 6 topics out there and say, who wants to do what? Okay. Um, Time is really short, so get them working on that, learning what they need to as early as possible. And then the third point here is really important, I think. Get to know your students as people. We're working on retention in underrepresented groups in science, and yet we treat them like they're just student A, student B. Get to know them as a person. Let them know that you also are a person. Find out their hopes and dreams. Chat with them about whatever movies they just watched. It's really nice. Your students are pretty interesting, and it helps you kind of meet them on their level and kind of know where they want to go. I'm going to try this, have groups share with each other, maybe do some rotations. And then I've heard this next one, keep a bunch of lessons, short lessons ready. I've heard this described as just-in-time teaching, right? And so there comes a point when students in their research, they're going to have to do PCR. Well, of course, they've done PCR in intro bio lab before, but also they know how to pipette, right? And so now they're having to look at that PCR and interpret it outside of there is a set answer we're trying to get for this lab, and it's much more difficult. And so I've got a lesson on PCR. What really is a primer? How do you design a primer? Just 5-minute things that you've kind of got in your back pocket that when students get to a wall, you can stop the whole class and say, everybody's going to need this at some point. Let's learn about the ITS regions. Okay. Give students a lot of leeway in how they self-organize in their group. Nobody wants the bad lab partner, of course, but try not to micromanage them. They're adults. They're good at this. Find room for fun activities when you can. I am going to try to have more guest meetings with mycologists because students really seem to love that. And then assessment, this one's tricky, but I've essentially just moved to ungrading and I let them grade themselves through that self-assessment at the end. Nobody has given themselves less than a B ever. Surprise, surprise. So in summary, if you try a cure, it's got a lot of benefits, but some cons as well. You're introducing the process of science and research to students more so than just content knowledge. Okay? You're getting a wide range of students excited about mycology. I mean, if they aren't already. You're reaching students that would otherwise never get a research experience. Who comes to you as a PI and says, I'm an undergraduate, I want to do research? It's the students who probably have had a mentor in their life that said, that's the thing you can do, or a family member that went to grad school. They know somebody who's done that and they see themselves there. Most students, especially first generation underrepresented groups, they're not going to approach a professor, a big scary professor, and say, I'd like to do research. Most don't know that that's an option. And so you've got a captive audience in your mycology course, for example. Boom, I'm going to bring research to you and show you that this is something you can do. You are a scientist. And if you want to continue this and get a more in-depth, longer-term research experience, here are 32 faculty that are willing to host you. Let's get you a spot. Okay. And this discovery-based aspect of it is really nice. The best part, though, is that they're all going to fail at some point, and that's incredible. Okay, it's hard to fail correctly, like in a learning way, during a set lab where there is an answer and you're just kind of going through the motions. Failure just means getting the wrong answer. Here, failure is an existential crisis for some of them. Okay? But the trade-off could be pretty severe depending on your perspective, and especially for like a graduate level course or where students are wanting to go into mycology, be a mycologist. The time for specific domain knowledge is dropped to nearly zero. None of them are going to know what a Spitzenkerper is. Okay. And this takes a bit of getting used to for the teacher and the students. I found that they do seem to love it though. All right. Now with my remaining few minutes, I'm going to acknowledge UVU, the university I'm at, is really great about undergraduate research. Not only do they say they support it, they actually support it with money, which is awesome. Make a plug for my mycology website where you can find resources, the syllabus, also the Hillbilly Mycology page for how to do mycology for pennies at home, and of course my students. But if you are this is more of a comment than a question person, now is your time to shine, because I've got a few minutes. Sarah said that although I can't take questions, I can take comments. I'm looking for feedback from you, just ideas that you have, kind of spitball, what might be a good balance between domain knowledge and scientific training? How could this work for a large course section? Just help me out here. I need help. Don't make me call on you. Yeah.
I love your approach. I think
Oh,
it's
thanks.
wonderful. So, and I don't think there's any right or wrong. I'll just say that I do something sort of similar, but I have figured out that over time, I do have a more traditional mycology class, and then I do the mycology research in a separate class.
I'm going to do that. That sounds awesome.
Hi, thank you so much for that. That was really awesome. I do not have suggestions about the domain-based mycology training, but I'm curious if you could provide students with like contact people in specific fields, and that maybe that would help them get the feeling that they got to know a mycologist on a more personal level.
Yeah, so I do a little bit of that. If it's kind of like an if they ask me, I say, well, here's somebody. And I have had students reach out to other professors to like, hey, how did you get this like technique to work and that kind of thing, which is super awesome.
Yeah, I think that's really intimidating
Yeah.
as an undergraduate to like actually reach to the author.
Oh yeah,
That's
isn't
really
that
cool.
crazy?
Well, yeah.
It's super exciting. I got to do that once as an undergrad and it blew my mind. So yeah. All right, well, I'll finish a bit. Oh yeah, sorry.
I was going to
We
say,
got time.
So for incorporating research and also kind of the large core sections, I tried to do this a little bit with a class that I got to TA and we got to structure the lab because I had an experience like this as an undergrad, and it's the reason I went to grad school. In my upper division microbiology class, they structured it where like the first 4 weeks was teaching us basic methods, aseptic technique, streak plating, all the stuff that you need to know, a little bit of basic bacterial physiology. And the last 6 weeks was propose a project, go out, swab something on campus, build a microcosm, do something, tell me something new about a bacteria I haven't heard before. So, I mean, that's bacteria. We can do it with fungi, and it's really rewarding for the students. I love this whole idea. So, I just was going to plug that in there. You could do like a 1/3 to give it your basic mycology, 2/3 the research project. So.
Awesome, thank you. All right, I think I'm out of time. Thanks.